Hey everybody, welcome back to some more story problems. So we're going to be talking, I'm going to do a couple examples of some story problems with you guys. These are trigonomic story problems, so we're going to solve them using trigonometry. So SOHCAHTOA, right? So our first problem, we have a pilot who is flying at 10,000 feet and wants to bring the plane up to 20,000 feet over the next 50 miles. What should be his angle of elevation? Remember, there's 5,280 feet per mile. So remember when we talk about angles of elevation or depression, we're basically starting at a straight line, right? Elevation would be the angle coming up from a straight line. So this is elevation. Okay. When it says coming an angle of depression, that's coming down from a straight line. Okay. Has to be coming down from a straight line. This is depression. It's very sad all the time. Okay. So elevation coming up from a straight line, depression coming down from a straight line. Okay. So with these trigonomic story problems, my advice is to always, really with any story problem at this level of math, draw a picture. I mean, you don't have to be the greatest artist, unlike me, but we can't all be as talented as myself. So so let's start out. We have our plane here, and it's going to be an amazing plane. So here's my plane. There's a wing. There's a wing. And there we go. Yeah, great. There's my plane. There's the little, pilot area. And here's my pilot. He's right there. He's got a math book because, what pilot doesn't do math? Okay. And let's give him an ice cream cone because, he's working hard. So got our pilot, got an ice cream cone, and he is currently at 10,000 feet. All right, so 10,000 feet here. Okay, he wants to get up to 20,000 feet. So here we go. Here's his flight path right there. And it's over the next 50 miles. And we're going to convert that to feet so that we're dealing with the same thing here. So there's his flight path. And so 50 times 5280, which is the feet in a mile, is going to be 264,000 feet. Okay, and then he's going to climb to 20,000 feet. Yeah, 20,000. All right. So that's where he's actually going to fly. Like that. So here's my right angle. It wants me to figure out this guy right here. That's my angle of elevation. That's my question mark. Now the difference from 10,000 to 20,000 is 10,000 feet, right? So he's going to climb 10,000 feet. I'm going to get rid of that so it's not confusing. So that's our two side lengths that have been given. So we have an opposite side and an adjacent side, and we have a missing angle. So this is going to be a inverse function. And opposite and adjacent is tangent, right? So to figure out that angle of elevation, I would do the tangent inverse of my ratio. Opposite is 10,000. Adjacent is 264,000. And that should equal my question mark. So let's try it out. See if we get it. So tangent inverse of 10,000 divided by 264,000. And I get 2.16, which again, rounded to the nearest tenth, which I think it says on the actual worksheet, but not here, would be 2.2 degrees. So that angle of elevation would be 2.2 degrees. And that's your answer. Not too bad, right? Once you got the, picture drawn and, the ice cream cone, that was very important. Let's give him a third scoop. Let's give him a fourth scoop. Very important. He is very ice creamed for his flight. All right, you can stop rolling your eyes now, guys. All right, let's try another one. So we've got a hot air balloon. It's 700 feet above the ground. The angle of depression from the balloon to an observer is 5 degrees. By line of sight, how far is the observer from the balloon? So again, we're going to start by creating our picture here. So here's my, basket that the guy hangs out in, right? Here's my guy right there. He's got a, slingshot. Because, who doesn't want to slingshot people from up high and, an ice cream cone? Because, it's a hot air balloon. And then this is all going to a balloon. So here's the balloon here. Yay, it's going up. There's the balloon. It ran into my word problem. Yay, okay. The balloon is 700 feet off the ground, right? So he's 700 feet high. Then I got to be careful here because this is an angle of depression, right? Angle of depression has to be coming down from a straight line. So I can't just say this is 5 degrees. This is not a straight line. So here is the triangle I'm actually going to form. So here's the dude on the ground. He's got the line going through his head. He's also got a slingshot. It's a bigger one. He's trying to, hit the guy up there with a slingshot. Okay. So, he is 700 feet below. And there's an angle of depression here of 5 degrees. So I want to figure out how far the observer is from the balloon. So I need to figure out basically the trajectory of his slingshot. I need to figure out this, right? The hypotenuse. So I know an opposite side length. I know the angle, and I need to find the hypotenuse. Opposite, hypotenuse, that's going to be sine. So you'd set it up as sine of the angle, 5, would equal opposite, 700, over the hypotenuse, x. Okay, and then you just solve, again, the x and the sine 5 would switch spots. X would equal 700 divided by sine 5. Again, basically, if you multiply by the x and then divide it by sine 5, they just switch, right? And then you just plug that into your calculator. 700 divided by sine 5. You get 8,031.59. I'm not sure what it wanted you to round to on the worksheets. So I'm just going to say 6. So x is going to equal 8,031.6 feet. 60. Right? And that would be your answer. And that's it. Hope that was informative to you guys. If you have any questions, let us know. We're here to help. And have a good day. Enjoy my artwork. Here's my balloon picture again. There's my, pilot. He's doing a good job flying the plane.